Hello, everyone, and welcome to Singularity One-on-One. Singularity One-on-One is a podcast feature of Singularity weblog, where you can go and listen to it or download it in full. As you already may know, my name is Nicola, aka Socrates, and as always, I will be the man with the questions. Today, my guest on the show is Dr. Randal Koene. Randal is one of the co-founders of Neuroengineering Corporation and carboncopies.org. In addition, he's also one of the associates of Halcyon Molecular. So without further ado, let me welcome Randal to Singularity One-on-One. Hi, Randal.
Thanks.
We're very happy to have you on the show today.
It's good to be here.
Fantastic. So let's begin with the first question. Randal, can you tell us how did you get interested in nanotechnology and neuroengineering?
Oh, that was a long time ago. I was only 13 years old or something like that, and I had so many hobbies, so many things I like to do, everything from writing and playing music, making music, anything. And after a while, it gets to the point where you realize that you just can't do everything. You realize that we're limited in our capabilities, we're limited in the time we have available, and that sort of irked me. And I thought, well, what would you need? You'd need more time and more capabilities, so you need to enhance yourself, you need to expand your life, and how could you do that? And it so happened that at the time I read a book by Arthur C. Clarke. It was entitled The City and the Stars. And in that book, there is a group of people that live in a city called Diaspar, where there's a giant central computer, and they get 1,000 years of life, and then they have to go back in the computer for a while, and then they get another turn later on, so that everyone takes turns. And I thought, okay, so maybe it's true. We're just information. Maybe we can just put that in a computer or something like that. And my dad is a particle physicist, so I thought this has to be physics. You need to decompose someone, put them in all that in a computer, all that information, and then recreate it from the bottom up, which is kind of what the ultimate dream of nanotech is, to be able to manipulate on an atomic scale and put everything together from the ground up. And then, of course, there's this whole problem of thinking and being and what are we, and it's in the brain, so there's the neural engineering part. And later I realized, as I was going through my studies, I started in physics, that, okay, maybe I'm tackling the problem the wrong way because I'm going at it by trying the hardest thing first. Maybe I should just be concentrating on the mind, since, I mean, what are we, right? You don't really know anything much about what's going on except for what you're processing inside your mind right now. You're processing sensory information. You don't even really touch objects because the atoms never actually touch. There's mostly space in between there. There's an electrical signal that travels up your arm, and you don't even know about the electrical signal either. All you know is how it's being processed in your mind. That's what you sense. And you've got memories and executive function and drives, and all of this together is really what you are. So I decided to concentrate on that, and that's how I ended up doing computational neuroscience and neural engineering. And yeah, that's where it all came from, and this was way back. And yeah, in 1994, that's when it became more formal. That's when I started working on the Mind Uploading Research Group, which was what it was called back then. It's a bit of a vague term, but yeah, 1994.
So what is so fascinating about, first of all, what is so fascinating about the science end of it? Like the fact that, as you said, you never touch the world around you. It's mainly space in between, atoms. And you mentioned the electrical signals and so on. What is so fascinating about this?
Well, it is, to me, it's really fascinating that you can have something that is basically a model. It's basically a model we build inside of our own heads, of the universe and of ourselves in it. And it's a representation. It's one of many possible ways that you could represent all of the different interferences that somehow in the end affect our thinking. It's just the inference between all those different atoms and how they interact with one another, forces that are happening. And all of this together somehow, that, photons, pressure and sound waves, all of this gets translated into one coherent model. And that's our life. That's what we are. This is where we are. And it could have been something else. It could have been that this would be processed completely differently. And in fact, We don't know if other species, like take insects, for instance, if they have a completely different type of internal representation, and if that experience, I mean, obviously they have very small brains, so the experience is quite limited and different anyway compared to ours, but even just in the way that it's shaped, it can be entirely different. And I find that really fascinating, that this is what we ended up with, this
So,
sensation of being.
so let me challenge you here on one of the points you made. You said that we're able to create a model of the universe. But does that mean that we should also be able to make a model of the functioning human brain, to make a model of our intelligence, to make a model of who Randal Koene is?
When you say we should be able to make a model of it, I'm not exactly sure what you mean by that, because when someone comes up to a neuroscientist and says, well, do we understand the brain, or do we understand this part of the brain? The neuroscientist always answers no. And they do that because even if they've studied the neurophysiology forever, and they've looked at the way that all the neurons interact with one another and what kind of synaptic channels are there and exactly what the action potentials look like, okay, great. That's a way of representing what's going on at that level. But what the person asking actually wants to know is usually something more along the lines of, do you understand why, when I'm thinking this, why it works out that way? Do you understand the strategy that the mind is using? Do you understand that strategy at multiple levels of the hierarchy of how it all decomposes until eventually you get down to the neurons? And then the answer is, of course, no. We totally don't, because we don't know how to combine this large-scale, high-level abstract stuff with that low-level simple stuff. So that's why the neuroscientist says no. Now, when you say, can we model this in our minds? No, I don't think so. I don't think that we can take all of that detailed information at the neuronal level and we can somehow build that construct as it goes up to an understanding of what it actually does, what the strategy is, and hold all of that inside of our minds. No. But what we can do, because what we're doing all the time is simply interpreting information that's coming to us and combining that with our memories and our understanding, we can use the computation that's happening outside of us and the rest of the universe to improve what we understand or how we can operate in that universe. So for example, I can build a computational model, a computational version of a brain outside of myself, in a computer, in some other operating environment. And because it is carrying out computations, it's carrying out interactions between elements, the results of that I can use, I can interpret. So it's not that I'm building an entire model of that inside me, but I have a model then of the universe that includes in it the understanding that there is a box over there that has a complete model of a brain in it. And that tells me things, and I can test it. I can ask it questions and get answers back, and things like that. So no, we don't build the model inside of us, but we build something else. And then our interaction with that becomes part of our universe model, our idea of where we are, how we're existing, the feeling of being.
So what does this say then about the possibility of mind uploading? How realistic or unrealistic is that? I mean, if you're saying that you do not believe that we could ever be able to replicate the internal structure, the neural structure of, say, Nikola Danielov here, how are you ever going to create a mind upload of Nikola Danielov? And is that feasible at all?
That's a misunderstanding. I didn't say that we couldn't make a replica of the neural structure of your brain. Why not? We could make a replica of all sorts of things, right? It's just that I was saying, you know, when you said, how do we make that a part of our model of the universe? I'm saying that the model of the universe that we hold inside of our own minds is not one that contains detailed information about the location of atoms and things like that. It's an abstract representation. So of course it won't contain that model. But other devices can contain those models, and they can contain them very precisely. So yes, I do believe that you can do that. In fact, I don't see any reason why you couldn't. I mean, why shouldn't you? If it's a machine that is basically, it's a biological machine that's carrying out processes that cause the activation that we can see when we look at an fMRI, for example, and the propagation of this activity, then you could make another device that can produce the same types of patterns of activity and their propagation, etc. So yeah, you could do that.
So that was my misunderstanding, and I apologize for that. But let's see then. Sorry, I have a horrible headache here, and I'm just trying to.
Oh, sorry to hear that.
To connect. I'm not connecting well. I
uh,
apologize, which is kind of funny when we're talking about it. My head is
Yes.
like bursting.
I know. I was just thinking, if you were actually a whole brain emulation right now, then you could probably just see where that pain was coming from and sort of tune it down or turn it off without using drugs. But you know,
That's fascinating. So let's grab that point then. So say Nick Danilov here has a horrible headache and therefore is unable to conduct a proper interview, but you have the ability to create a replica of my mind by uploading it to another substrate, which then in turn can conduct the interview for me while I go and take a break, for example.
Yeah, absolutely. Why not?
How crazy is that as a possibility? Is that science fiction entirely, or is it a possibility that you see happening?
No, it is not science fiction. It's science. It's not science that's here tomorrow, but it's also not science that's here 200, 300, 400 years from now. I haven't, okay, so there's a number of publications that I've been writing up recently, and it so happens they're all going to be showing up somewhere in early 2012. And they're about the actual projects that are currently ongoing that relate directly to the sort of things that need to be done to do whole brain emulation. And these are the sort of things that, while we can't tell exactly how many hurdles are going to be in their way, so we don't know if it's going to take 5, 10, 20, 30 years, it's pretty sure that when you look at the type of project they are and the fact that they depend on today's knowledge, today's science, and today's engineering, that these are not things that require some sort of magical ingredient that we need to wait for a couple of 100 years. It's not science fiction at all.